Hello, today I'm going to talk about the Caja del Rio Plateau near Santa Fe. The site is located on top of a mesa within the Caja del Rio Plateau, a few miles west of Santa Fe and east of the Rio Grande. The site contains both pinyon pine and one-seed juniper woodland and also a big sagebrush ecosystem. Other understory vegetation includes rabbit brush, blue grama, and other cactus species. The fire return interval for sage would have been anywhere between 70 and 200 years and would have been very spatially heterogeneous. The community probably was maintained by periodic fires spaced far enough apart to allow time for the shrubs to recover. Pinyon juniper fire return intervals in the area also varied widely and were spatially heterogeneous. The intervals might have averaged between 12 and 25 years in some places, up to hundreds of years in others. Fire was often high severity and stand replacing. Fire may have maintained grassy and shrub expanses, and fire exclusion due to grazing may have allowed pinyon juniper woodlands to expand, although few fire history studies have been conducted to confirm this. This area is owned and managed by the U.S. Forest Service, and in the early 2000s, the top of the mesa was treated using a combination of mastication, hand thinning, community forestry techniques, and prescribed fire. Observations in the area, conversations with local managers, and reports from the time lead me to believe that the study site was cut using a machine such as a feller buncher, and the trees were cut at the base and limbed with boughs left whole, but not ground to chips. Then the area was open to firewood cutters. This is supported by the lack of large bullwood on the site in many cases. I did not observe any indication that the study site was burned. Geospatial data from the New Mexico Vegetation Treatment Database generally confirms these observations and treatments. However, exact boundaries of the cutting units were not provided. The treatment database states that the management objectives were to restore the big brush sage communities for wildlife benefit. As you can see in these photos from Google Earth, before 2004, there was no treatment, and then you can see the clear line where treatment happened. So as I just mentioned, the northeastern side of the site is a pinyon juniper woodland, while the southwestern side is a sage ecosystem. And this photo kind of shows the dividing line, although in the last 15 years, juvenile junipers and pinyons have begun filling into the sage area, most densely right along the cut line where there's a seed source. The size of the area I chose to study is approximately 40 acres across the treated and untreated areas. The objectives of my measurements were to see what differences in fire risk and intensity are between treated and untreated sites, especially now that the treatment is about 15 years old. I'd like to see what the difference in surface fuels is in the form of slash on the ground as opposed to standing trees in the PJ woodland and how this will have an effect on fire risk and intensity. I'd also like to see what difference there is in juvenile regeneration between the treated and untreated stands. I established 8 plots in a systematic grid to ensure there were 4 plots in the untreated side and 4 plots in the treated side. At each plot I used a 10th acre subplot to count seedlings, saplings, and mature trees. Seedlings are those less than 5 inches at the root collar and less than 4.5 feet tall. Saplings are less than 5 inches at root collar, higher than 4.5 feet tall, and mature trees are bigger than 5 inches at the root collar. I also used 2 brown lines at each plot to measure surface fuels. To measure pinyon, juniper, and shrub live fuels, I used the photo guides titled Guide for Quantifying Fuels in Sagebrush Steppe and Juniper Woodlands of the Great Basin and Guide for Quantifying Post-Treatment Fuels in the Sagebrush Steppe and Juniper Woodlands of the Great Basin. This photo guide provides estimates of fuel loading in shrubs, canopy, and litter fuel loading based on ocular comparisons of the photos of the guide. And although none of these plots were established in New Mexico, I felt it was a pretty close approximation. Surface fuels were calculated using brown lines in the accompanying calculations. Litter and duff was calculated using measurements from the field and bulk density measurements from the photo guides. Live fuel loads were calculated by comparing photos taken in the field with the photos from the guides and then using those measurements. Live tree density was taken from counts from the field. The treated ones were calculated in the same way. Here we see that the treated areas had lower fuel loadings in all categories except the 1,000 hours for surface fuels. Also, here we see there were no adult trees, but juveniles were present. Next, I needed to determine fire behavior using the Behave fire model, but to do so I had to find values for fuel moistures and wind speeds to plug into the model. To do this, I used the 3 closest RAWS stations to the site and analyzed their data with Fire Family Plus. The tower RAWS is the most similar to the site in both elevation and vegetation type, so I weighted that RAWS station with a 1. The other 2 closest RAWS sites in the Santa Fe watershed and the True Trust area are both slightly higher in elevation and in pine ecosystems, so these were weighted with a 0.5 each. From these RAWS stations, I looked at graphs of the last 11 years of data for the typical fire season in the area, which is March through July. These graphs show that clearly June is the highest fire hazard based on the surface fuel moistures. June is when these values bottom out before the onset of moisture from the monsoon season. For the month of June, I pulled high, average, and low fire danger situations. These were based off the extreme highs for the month of June, as well as the extreme lows and then the averages. So these values included 1-hour fuel moisture percents, 10-hour fuel moisture, 100% for live herbaceous and live woody fuel moisture, and then 20-foot wind speed. The 20-foot wind speeds were then converted into mid-flame wind speeds for the treatment and untreated areas by using the wind adjustment factors. These behaviors were completed with existing fuel beds that were then modified with the fuel measurements from the field and from the photo series. The behavior runs were calculated using the 3 weather situations from the 3 local weather stations explained before. The low fire danger situation pushed the model below the moisture of extinction and thus resulted in almost no fire activity. In summary, the untreated area had higher surface fuel loadings than were recorded in the treated areas. This could have been due to a large number of dead piñons in the untreated areas than were in the treated areas. Likely these piñons were killed during a bark beetle outbreak that happened sometime after the treatment, though it's hard to be certain. Also, the treatment in the treated area had happened long enough ago that the smaller fuels had begun to degrade, leading to lower amounts of 1-hour and 10-hour fuels, where the dead piñons in the untreated area were more recent. Also, there was a high density of seedlings and saplings in both areas, but it was higher in the untreated area, due most likely to the seed sources of nearby adult trees. Lastly, the measures of fire movement and intensity from Behave showed that the treated area had a much higher rate of surface movement and intensity in the highest fire danger conditions. I suspect that this larger amount of shrub fuels is what's driving the difference, since the surface fuels are relatively similar. Unsurprisingly, the canopy fire flame lengths are much higher in the untreated portion of the unit due to the higher canopy heights of the fuels. The canopy spread rate, however, stays the same across both sides of the unit, and I assume this is because this portion of the model in Behave is much more weather driven, and when it reaches those extreme situations, it produces the same results, regardless of the fuel. So the average weather conditions for June showed moderate rates of spread and flame lengths. So fire in these situations would threaten homes and infrastructure if there was any nearby, but they're mild enough that they'd have a high probability of being able to be suppressed by firefighters. but both of the fire situations in the high fire danger case would pose huge threats to any sort of development and be very difficult, if not impossible, for firefighters to suppress. If you had fuel situations similar to either of these, you would need to really reduce them to prepare for the most extreme weather. However, since this treatment was initially for habitat improvement, I think the amount of fuel is okay, and most likely a fire would happen in the more average situations and be relatively easy to contain. Also, the Caja del Real area is relatively remote and broken up with many natural fuel breaks that would stop or slow fire spread. So at this time, I feel the more pressing need is to just retreat the sage ecosystem where the juniper encroachment is happening along the seed wall. This will probably preserve the ecosystem for at least another 15 years, which is how long it's been since the previous treatment. Also on this slide, I put a picture of this lava tube that's really near the treatment site.